The rest of the problems on this lesson do not use formulas from your formula sheet. In all of these problems, they will give you a formula to use and apply. So let's read example 7. In 1619, Kepler discovered the relationship this. So let's box this in. This seems important. It's an equation. It's probably the equation we're going to use for this whole problem. If it helps, I would put parentheses around the t and the d so you can see what's inside the log. Now, this relationship is between the period t. So let's make some highlights. T is the period, or the time it takes to complete one revolution of the sun. So t is one time around the sun in Earth years. So if you think about it, time to go around the sun in Earth years for Mercury isn't going to be as much because it's a lot closer to the sun, versus like Pluto is going to take a lot longer to go around the sun because it's way on the outskirts. So that's kind of what we're talking about here. So this is the relationship between the period in Earth years of a planet and its average distance, d, in millions of miles from the sun. So d is the distance from the sun. Although at that time only 6 inner planets were known back in 1619, this formula actually correctly predicted the periods of all the other planets unknown at the time that were discovered later. So it's kind of a cool formula that it worked for the things they knew at the time and continued to work for all the new things we discovered. So our question is to find the period. So we are finding t of the planet Uranus with the average distance of d, 1783 million miles. Now, d is already in millions of miles, so I should just be able to use 1783 for my d. So, let's plug this in. We have log of t equals 1.5. Log of my d is 1783. And let's color code our t. That's what we're solving for. Minus 2.95. And I want to solve for t here. Now, there are many different ways you could go about solving this, but there is one way that is much faster than any of the others. Is right here, I have a t, and if you think about it, all of this I could just put into my calculator and get a decimal answer. So this whole right side is just a number. And if I think of this whole right side as just a number, then I can actually just change the form right now, where this base is a base 10, and I think of this whole number as the input. So that becomes my input, and my t becomes my output. And right away, you already have t solved for. So it's kind of weird to think of this whole thing as your input, but you are totally welcome to do that because that is all just a number. There's no other variables in there. If I had more variables and letters in there, then I might have to do some things differently. But in this case, I can just type all that into my calculator and get 84.47 years. So this is the time it takes for Uranus to make one revolution around the sun. It takes about 84.5 years, Earth years, for it to do that. So that's one example. Let's do another example. We have a defrosted turkey at a temperature of 32 degrees, and it's placed in an oven that has a constant temperature of 350 degrees. So we're cooking a turkey dinner. Maybe it's Thanksgiving. The temperature of the turkey after t hours cooking in the oven is this. So it looks like that is our equation that we're going to use for this example. Now let's label some things. It says where K is a constant, so that's probably like our rate of growth again. So K is our rate of growth. It says if after 2 hours, so that's going to be a time, the temperature of the turkey reaches 125 degrees. So that seems like that's going to be a final temperature. So that's going to be our T of T, our final temperature. Find the constant K. So that's the first thing I'm going to do, is I'm going to plug in T and T of T and find K. I'm just going to ignore the last sentence because I can only do one thing at a time. If I try to read it all, I get overwhelmed. So let's plug in what we know and just solve for K first. That's my T of T. I do not know what my K is. That's what I'm trying to find. And my T is 2 hours. So how long is it going to take this turkey to heat up from 32 degrees to 125 degrees? Well, let's solve this. So I can minus 350 on both sides. So I get 125 minus 350 is negative 225 equals negative 318 e to the 2k. Divide by negative 318. Don't simplify that yet, although I can say that two negatives make a positive. Change the form. And divide by 2. And now I have found what K is. This is the rate of growth. How fast this turkey is heating up in this oven. Now, notice I didn't turn it into a decimal because I know that's not my final answer. I still need to read the last sentence. Now it says, determine how long it will take for the turkey to reach the safe consumption temperature of 172 degrees. So that sounds like a new T. That's a new final temperature. So my turkey is heating up from 32 degrees. How long is it going to take for my turkey to heat up to 172 degrees? So here's my equation. And this time in my equation, I know what K is. I solved for that. 225 over 318 all over 2. And it looks like this time I am solving for T. I'm solving for how long is it going to take for my turkey to reach 172 degrees. So, using all the skills you've learned from this lesson so far, I would like you to pause the video and try to solve for T on your own, and then come back and check your work. Check what you got with what I got. So, I went about solving this. Notice that when I changed the form and got to this step, I multiplied by the reciprocal again instead of dividing by a fraction. So then that way, once again, I don't have fractions in fractions. And then when I multiply by the reciprocal, I just put that over 1 and then multiply straight across and put that in my calculator. And that gave me 3.3 hours. So my turkey needs to cook for about 3.3 hours and then it will be safe to eat. Last example of the day. This one is not a logarithmic problem, it is actually an exponential problem. And it's a very special type of exponential problem called a logistic equation. So, let's talk about this one. The number of students n in hundreds, so we have some sort of n that is in hundreds, and it's the number of students at Salt Lake Community College who have acted on the rumor, free popsicles at the library, and received a free popsicle, can be modeled using this equation. So it looks like this is the equation I'm going to use, where I already know n is the number of students in hundreds, and it looks like t is the number of days after June 4th, 2018. So, two questions. First question it says is how many students got a free popsicle on June 4th, 2018. So if it is June 4th, 2018, that means my t is going to be 0, because that's the date I'm starting on. So basically we're asked first to start with this equation and plug in 0 for t to see what we get. Well, that is already all solved. I can just type that whole thing into my calculator. Type that into my calculator, I get 0.03. And remember, this is hundreds of students. So if I times this by 100, that also gives me that there are 3 students. So on the first day that this rumor starts spreading about free popsicles in the library, 3 students have gone to get a popsicle. Next, it asks, after how many days will 4,200 students have picked up their free popsicle? So that is now an n. So I'm going to plug 4,200 in for my n. And now I'm solving for how much time it's going to take for 4,200 students to act on this rumor and get a free popsicle. So this is a very different kind of equation than we have solved before. Oh, I just realized I made a mistake. I don't want 4,200 because remember, n is in hundreds. So I actually only want 42 because it's in hundreds. Oops, that was close. So let's go through and solve this one together because it does look quite different from everything we've done before. Now, as per usual, we always times by the denominator first to get it out of the denominator. We don't like things down in the denominator. And this 42, I'm going to distribute. So 1 times 42 is 42. 2,799 times 42 is 117,558. And then I have my e to the negative t. And that all equals the 84 that's left. Now this is much easier to solve. You should be able to solve it from here. So I would like you to pause the video at this point, solve for t from here to find out how many days until 4,200 students get a popsicle. Let's check your answer. So I subtracted 42 first. 84 minus 42 is 42. Divided by this basically to get my exponential alone. So then once my exponential is alone, I can change the form to ln, input and output flip places. And then the last thing I need to solve for t is to divide by a -1. So I put all that into my calculator, and I got 7.94 days. So it's going to take almost 8 days for 4,200 students to come and get their free popsicle. Hopefully they're not melted by then. Anyway, that is all for 4.5. You are officially done with Chapter 4 on exponentials and logarithms. You are a pro at story problems. And when we come back for Chapter 5, we will start into a totally different subject, which is conic sections.